Welcome back to Get Git, Introduction to Version Control with Git and GitHub. This is video 4 of our workshop series. So if you haven't seen the other videos, you might want to hop back in the playlist to see what you've missed. The outline for the for the workshop is a website that you can get the link in the description down below, so you can follow along there. There's all of the code and commands that we're going to run that you can copy there and just follow around step by step. So in this section, we're going to go over the basic Git workflow. It's something that we're going to repeat over and over again, and we're going to do it on the command line so that we really get that sort of fundamental understanding of what these commands do and kind of how they work together in a workflow step by step. So we set up a demo repository on GitHub in the earlier videos, and we need to copy that down to our local machine and then start editing those files. I'm going to use this little sketch here, which is essentially my artistic representation of how Git works, and we'll refer back to this process as we go through the steps and go through the commands step by step in this demonstration. But the first thing that we need to do is go ahead and make the copy of that version of this folder that is up on GitHub and make a copy down on our local machine so we can work on it. And that command is called git clone. And so that's where we're going to start. So what I need is, here's my Finder or my File Explorer on Windows, and I need to open up my terminal. So I'm going to just avoid having to navigate over and around through the command line. What I like to do is just right click on that folder, and we have this option in the context menu that says Git Bash here, and the same exact kind of option is available on Linux and on Mac. So that just kind of saves you some time navigating through all the folders. I'm going to make this terminal window a lot bigger and zoom in there so it's a little bit easier to see on the screen here. Okay, so I have my terminal open. I'm in this location, which is in my documents, and it's called demo. So what I like to do is, you're going to be cloning a repository down from GitHub and onto your local computer. And your repository, again, is just a folder of files. And so what I want to do is keep my folders that I use on GitHub organized. And so I like to set up a folder there that I'm just going to call GitHub, and I'm going to put all my repositories in there so that I know kind of where they are and where they came from. So on the command line we can do that. We can say mkdir, which is make directory, and then I do space and then you give the name. So I'm going to just say GitHub, and then press enter, and that will create that folder. And you can see over here on my Explorer, hey, there's that folder that I just created. Now I want to go inside that folder, so I'm going to do on the command line cd git, and I start typing GitHub, but then I can just click tab, and the terminal's smart enough that it knows there's only one thing in there that starts with GI, and it's just going to finish that name for me, so I don't have to type it all out. Then I'll press enter, and you're going to see that my terminal has actually moved its location. It is now actually inside this folder. So I'm just going to do that on my Explorer so I can see where I'm at. So here I am in this empty folder called GitHub. And so I can do an ls, and you can see there's nothing in there. So there's nothing that it says. So now I'm going to go to clone. I'm going to go over to my demo repository that I set up earlier in this video series. And so here's your repository on GitHub. We're on the code tab, the kind of main homepage for your repository. And there's this green button here that stands out. It says code. And if you click there, it's going to give you a drop down, and it has clone. It has some other options here, but clone is the one that we want to use. And so we want this HTTPS link, which is just a URL to the GitHub repository, or the Git repository on GitHub, and there's a little copy button here, and so I'm going to say click that to copy that to my clipboard. And once I do that, I can hop back over to my terminal, and I'm going to start my commands just like we have been with git space. So that's the application I want to use, Git, and the command that I want to use is clone, which is going to be the command to copy something off of a remote, in this case GitHub, and bring it down to our local machine. And so we need to give clone that link that we just copied off of GitHub. And so I can paste that in there. I do a Control-Shift-V to paste that in there. You could also right click and use paste to get that into your terminal, because you probably don't want to have to type that in to complete that command. And once you have that link in there, you're going to press enter to give that command to your terminal and run it using Git. So I'm going to press enter. And it's going to give me some information about what it's doing. So it's saying it's cloning it into a folder named the same thing as what the repository is named, and it's kind of giving me some results of what happened. So it's basically just downloaded a folder of files. So we can go and look now in my file explorer here, and you can see that in this folder that I set up, GitHub, and I went in there, I now have a folder called demo repo today, which is exactly what I had up here on GitHub. And now I have a copy of that located on my computer, on my desktop. So I can go into that folder, and this, as I said, is a regular folder files, just like any other on your computer. And so what we see inside that folder is 2 files, which is exactly what I had up on GitHub, readme.md, example.md. And so I have 2 files now in this repository. And the other thing that you're seeing here in my Explorer is this hidden folder called .git. And so I have my Explorer actually configured to show the hidden files. You might not have that set up. And this hidden file right here, this folder, is actually what the Git repository is all about. And it's hidden for a reason. You don't ever touch it, you don't interact with it, you don't open it, you don't edit it. But that is where your history of this repository is actually stored, and also all the configurations and that connection back up to GitHub. So if you want to be able to see your hidden folders, there's usually an option on your Files app on Linux or on Mac. And on Windows, if you are on your Explorer, there's this area where it says View, and right here are some options. So I clicked show the hidden items, and I also really suggest checking this box where it says file name extensions. Showing these extensions makes it a lot easier to understand what files you have in there, and it's important to have the correct extensions when you're working with code and plain text and data. And so being able to see those extensions, I think, is important. So on your File Explorer, View, file name extensions, check that box so that you can actually see those extensions and it's not getting hidden away by Windows. So this .git folder, don't think about it, don't edit it, don't worry about it. But these regular files in here, those are just the regular files, and like any files that you have on your computer. So now I did this git clone. I've made a copy of this folder, but my terminal is still located here in this GitHub folder. And so if I want to start using Git now, I want to change my directory into that new repository that we just downloaded. So I'm going to do a CD, and I start typing demo. I click tab to tab complete it. And so that automatically finishes off the file name for me, or the folder name for me. And then I can press enter to move my terminal's location into this folder. So now my terminal is in the same place as this in my Explorer right here. So we cloned a copy of this repository off of GitHub, and we brought it down to our local machine so that we have our own local repository on our file system. And the first thing that command that we'll need to know is called git status. So we say git space status and press enter. And so Git is just going to check what's going on and give us an update. So it's just saying we're on the main branch, it's up to date with GitHub, and there's nothing to commit. Everything's clean. So we're going to use Git status constantly. It has really helpful information. It usually gives you kind of like what is the next step that you might want to do. So it gives you some hints about how to use Git as you type it in there. And the other thing that you should also know is you can add the flag help. So Git status dash dash help to pretty much any command on Git, and it was going to give you some very detailed help information. In this case, it's sending me over on Windows to a manual page that's going to help me understand what the options are for the command that I'm trying to use. So there's lots of help built into Git. There's lots of hints built in when you use the command git status. And so use it and pay attention to what your terminal is telling you because it really is going to be some helpful information. So what we want to do is edit a file and see what happens. So the first thing we want to do is just go ahead and let's create a new file inside of our repository. And I'm just going to do this on the text edit or on my terminal just to simplify things for this demonstration. It's probably not something that you would normally do. And so I'm going to use the command echo, and I'm just going to put some text inside some quotes, so some interesting notes. And then on the terminal, you can use this caret sign or the greater than sign, and that's going to pipe whatever I wrote in that first command into a file. So I'm going to give a file name notes.txt, and if I press enter at this point, you're going to see that actually just creates a new file, and I can see it in my Finder here. There's a new file called notes. I could open that up with my text editor. So here's that file in a text editor, Notepad++ on this case on Windows. So you don't need to do this on the command line, but I'm just doing that to simplify doing this demonstration. So we've added a brand new file into this repository, and so let's check up on what's happening, what Git thinks. So we're going to say git status again. So Git now has a lot more information for us. It says that there's a untracked file. So that's a file that Git hasn't stored into the history at all yet. And so it also gives us a hint. You might want to do a git add and the file to start adding that into your staging area. And so that's a good hint because that's what we have to do. We want to add that notes into our staging area so that we can tell Git that we're ready to include this untracked file into our next commit. So we're going to do that command, git add, and then I'm going to give that file name. So I'm going to start typing no, and I tabbed completed, and so it completed that file name for me, so I didn't have to write it all out manually. And then I'm going to press enter. And this is just a warning that you're going to get if you're on Windows about line endings, because Windows uses a different style of line ending than Unix. And so Git repositories are designed to be used in a Linux file system, but on Windows, those line endings will be managed for you by Git, so you don't really have to worry about it. The next thing is let's check on that status again. So now it says that we have some changes that are staged to be committed, and so we have this brand new file called called notes.txt, and it's ready to be committed. And so the next stage, or the next step in this process, is to give that commit message, kind of like we did on GitHub on the web interface. We need to create a commit, and so that is another command. So we start with git again, and the command that we're going to type in there after git is commit. Now we need to also give a message with our commit, just like we have practiced before. So we have to give it the flag -m for message, and then I'm going to put a quote sign there, and then I'm going to type the message that I want to associate with this commit. So I'm going to say add notes file, and then I got to end that by putting the quote around that bit of text. So it starts with a quote, the string, the text that I want to use as a message, and then a quote file. And again, you want these commit messages to be small. It's one line, really, that is very clear about what you're doing in this commit. What is it doing for the repository? What is the feature that it's tweaking? What is the bug that you're fixing? What are you adding to this repository? And so you're going to do git commit -m for the tag, or the flag is message, and then quote your commit message, and then quote to end that. And then we're going to click enter to give that command to Git. And so we get a little bit of output from Git saying that something happened. We made a commit. Here's the message, or here's the message that we gave it. Here's this unique identifier of that commit in the history, and it's giving a little summary of what has changed in the repository because of that commit. So we'll do git status once again just to see where we're at. And it says now, again, we have a clean working tree. That means there's nothing changed from our last commit, but it is giving us this note that it's saying we are ahead of origin main by one commit, because now on our local machine we've created a new commit, but that is not automatically synced up to GitHub. It's not going to be synced up to GitHub until we do a git push to push all of our local history back up into the remote. And so it's important to keep that in mind, that that's not an automatic thing. This isn't automatically syncing like maybe Google Drive does, and there's reasons behind that in terms of that you don't necessarily always want to push everything up to GitHub immediately. So our final step after we do some other commits is going to be doing that git push, but we are going to make a couple more commits as practice before we do that, because we don't have to do it every time that we create a commit. So let's take a look at kind of what that looks like in my workflow diagram here. So we started out on GitHub with the repository that we set up. That's the remote. And then we used git clone to make a copy of this folder, and we bring it down onto our local machine. And there's two kind of parts to that, is that we have this copy of the history, which is the .git directory, so that actual history of the repository is copied down to our local machine. And then the other part of that is that this working directory. What are the files that we actually see in this folder that we can use, that we can edit, that we can work with? And so when we did that git clone, we copied the history down, and we copied the current version of all those files and put it into the folder so that we can start editing them and working with them. And so that's where we were at. Now, we were in this working directory, this folder of files. We created a brand new file. And so it's something that wasn't yet stored into that Git history. And so to get it into the Git history, we first added it into the staging area. And so the staging area are the changes that you've made to that working directory since your last commit. And you add the set of changes that you actually want to capture in the next commit. And the reason why you have this staging area is because you don't have to do a one-to-one commit, one file, one change, one commit. You can actually add as many changes, as many files that are different from the last commit as you want into that staging area, and make them all as a batch. So really, when you are creating a commit, you want to create a topical set of changes. So I might go into this repository and change 16 different things, but there's 3 of them that are related to fixing one bug, and so I would add those 3 changes together and create a commit saying fixing bug A, and then I would add the other 13 changes that I made together and say fixing bug B. So it's 2 commits, and so that's why you have that changing area or staging area, so that you can kind of group the set of things that you actually want to commit together before taking that snapshot of the repository and then permanently storing that into that Git history, the copy that is on your local machine. And so that's how far we've gotten so far in this diagram. And let's just go ahead and do another round of another commit, just to kind of repeat that process and reinforce what's happening there. So in this case, I'm just going to add some more notes. I'm going to edit this notes file, and I'm just going to do it this time with a text editor. So I'm going to open it with Notepad++. And so here's the file as it is right now. I'm going to press enter. Some more interesting notes that are important. And so I've just added a couple new lines to that file. In my text editor, I'm just doing a Control S to save that file, and then I'm going to close it. So now I've actually changed this notes file in this repository. I used the text editor, not the terminal, because that would be it's a much more normal workflow. You're probably not going to spend a lot of time editing files in your text or in your terminal. And so now I'm going to do a git status to see what's going on. And so now we can see that it's still giving me this thing that we're ahead of that remote. There is some changes that have not been staged for the commit, and it can tell that our notes file has been modified, which is what you just saw me do using my text editor. And so the next step it's saying is to use git add, and so that's what I'm going to do once again. So I'm going to look at this diagram here. So what we're at is I went into this working directory and I changed something. So it's different than the versions that are actually stored in this history. And so Git is telling me that something's changed, and if you want to commit it, the next step is to add. So we're going to do the git add again. In this case, rather than typing out the file name, that individual file name, I've only made one change, and I just want to add them all. And so I'm going to use the flag dash capital A to git add everything, all the changes that are out there. And so it's doing that. And so I can do a git status again. If I want to check where I am at, it says there's something stored in that staging area. So again, if we look at our diagram, I made some changes. I did a git add to put it into that set of changes into the staging area, which is just again prepping it, saying these are the ones that I want to commit in this commit, the changes that I want to capture to take a snapshot of in this commit. And so now I'm ready to make a commit. And I got to give it a message, -m, quote, and more updates to the notes, and end that with a quote. Now, if you forget to give your commit message, that's when Git is going to pop up the terminal text editor asking you to give that commit message, because it's required to have something in there. So just always remember to do that flag M and give your message. If you need more space to create your message, it's common that sometimes you will have a short message, so more updates to notes, and then you want to add a little bit more detail. You can, if I don't put this quote sign here, I can actually press enter and just start continue writing my message on a second line. And so if you have more information that you really want to make sure is associated with this commit, you can always you should use a short description and then go down and use additional lines to add more information. And then I can end that with the quote sign and press enter to finalize this commit. Ooh. I'm going to Control C that. Sorry, I did something wrong there on git bash, but we'll just get back to a regular commit. More updates to notes. I'm going to close that with the quote sign, and I'm going to press enter to make that commit. Okay. Sorry about that. So this was the command I gave. This is the unique identifier of this commit. Here's the message that I gave it, and here's the summary of what has been done. Essentially, one file was edited, 4 new lines were inserted in during that commit. And so this is a step. We added it, and then we just used commit to actually take the changes that were put into the staging area and permanently store them away in our local Git history on our local machine. So we now have all these current files and stored away with a couple of commits that we've just created in our local Git history. So now it says we're ahead by 2 commits from the version that is up on GitHub. So now let's just go ahead and edit 2 files just to show you what that looks like. So if I open up the example in a text editor, I'm going to add one more line here and Control S for saving it. In my notes file, I can edit something there. Maybe I want to put something up here. And I can do a Control S again to save that. And then we're going to go into our terminal again, and we'll do a git status. And now it can see that we have 2 modified files rather than just 1. And again, I can add them individually if I didn't want to add all of these files at once, or I can add them all at once to my commit. So maybe even I want to also add a change to my README. And Control S to save that. And if I do a git status, it's saying that all 3 of these files have been modified, and it's saying you want to go and do your git add if you want to set up a commit. And so one important thing that can be a bit confusing is that commits are not the same as saving a file. So whatever tools you're going to use to edit those files in this repository, these are just regular normal files on your computer. So if you're saving them, you're changing it, Git knows that. But that save does not trigger a commit, and commits do not trigger a save. And so those are totally unrelated processes essentially in the file system. So Git is tracking this folder of files. What you do inside that folder of files is up to you. You can use whatever tool it is that you're using. Let's say you're using RStudio to write some code. Let's say you're using a text editor to write some content, or you're using some sort of Python integrated development environment to create a project. So those tools aren't tied directly to using Git. Git is just tracking those files, just doing that version control. It's not related to the editing of those files. It's not related to the saving of those files. And so you want to be able to keep those that distinction between that, and don't let it confuse you. So right now I've just used a text editor. I edited all 3 of the files that are in my repository, and I want to stage those all together because it's a related set of changes that I've made. So I'm going to do a git add, and I'm going to use that all flag. So I'm going to do -A to add them all and press enter. And so I've taken, I went into my working directory, I edited those 3 files. Now I've used git add to add them all to the staging area. And so now I want to capture that commit and store it in my history. So I'm going to do git commit. I'm going to do -M to give it a message, quote, and give it a message, and quote, and press enter to give that command to Git. And so now we've got the summary once again, unique identifier of that particular commit, and it says that 3 files were changed and that there was 8 insertions. So there was 8 new lines created during that commit. Okay, so let's give us one more git status here, and everything's clean, but it's saying, you're 3 commits ahead of origin main. So the origin main again is that remote up on GitHub that we started from, and so This is just a convention. Origin is just a standard way of naming that remote version, that primary branch that you have up on GitHub. And then this is the branch name that you're working on. And there's a convention, again, just to call the main branch of your repository main. We're going to talk more about branches in the next video, but for now, your repository is going to start out by default with one main branch, which we're going to call main. Now the convention used to be to call that branch the master branch, and so you're going to see that in a lot of older repositories, but most people now are naming that primary branch the main branch. And so it's just convention. You can name it actually anything you want, but following the conventions is going to make working with it a lot easier. So as I said, importantly right now, we have all this changes that we've made stored in this .git repository, literally this little folder of files on our local computer, and they are not up on GitHub. And so we need to do the final process, which is to take this local history and push it up onto the remote so that we can finish syncing that project, so that we can go up to GitHub and see what's happened. So if I'm on GitHub right now and I refresh here, you're going to see that the history here still just says 4 commits, which is the ones that I did when demonstrating the web interface. And so we don't have these new parts of the project that I've just created. And so what I need to do is this command Get Push, which is going to take what I have on my local machine and push it up onto GitHub. And we can give the branches that it mentions here, origin and main, if we want to specify where we want to push it to, and then press enter. And what we're going to get is Git is going to contact that web version of the repository. It's going to compress the objects and send the changes, essentially just sending the history. So it doesn't have to take all those files as they actually are on my computer and send them up there. It can just send the information from that Git history and send them up to GitHub. And so it's a very efficient use of the bandwidth and of your data. So it's a good way to work. So I've done my Git push, and in most cases you really don't need that origin main added on there. We can just use Git push and it'll do in any normal workflow the same command. So we can just do Git push. But now it says we sent it up here to this remote repository, and we took the local main branch and we added it up to that remote main branch, the tracking branch. And so if we go back over to GitHub and click refresh, you're going to see that that history is now here on this remote. And so I can click here on the commits again to see all of this work that I just did on my local machine. And you can see we have these 3 new commits that we just experienced in this demonstration, and we can look and see what sort of things happened. So in this case, changing all 3 files as a demo, it says there's 3 files changed, there was 8 additions. So that's basically the same output that we got from Git here on the command line, but now we're seeing it in a more visual way on this website, which is a nice way to be able to view the history. And you can see the green is highlighting the lines that were added, and red would highlight any lines that we deleted. So we completed our Git push. We got our commits that we've done locally up on to the repository. The opposite of push is to pull. So we started today with this demo where we had set up a repository on GitHub, and we needed to make a copy of it down to our local machine, and we used git clone to do that. Now we already have a copy of this repository on our computer, so now we don't use clone anymore. So instead, to keep this repository up to date with what's on GitHub, we'll have to use the command git pull. So to demonstrate that, what we're going to do is just head over to your repository again, and let's make a new change here on the web interface to see what that looks like. So if we go over to this example.md, I'm going to grab this little pencil button to edit the file, and I'm going to just put a new line in. Okay, and I'm going to scroll down and make that commit on the web interface. So if I go back to my home, you're going to see we now have 8 commits up here in our repository. And if we go back over to our terminal and we do a get status, you're going to say that our local doesn't know anything about that commit. It didn't update anything. It doesn't ask automatically for GitHub. So there's no automatic syncing here that's taking place. So we actually need to do that manually to make sure that we have all of the history up to date on our machine. And so the command for that is going to be git pull. So we know that I just created that new commit up there. And so we're going to do a git pull now to get that on our local machine. Git pull, and we don't have to give it any qualifiers because it's just, it knows where to pull it from. And press enter. We're going to get a little bit of output letting us know that it went up to this repository, that remote that we have, and asked for some information, and it found out that there is actually some changes in our history, and it'll actually give you a little summary of what changes have happened. And it doesn't actually say the commits, it says all the changes that have happened, kind of summing it all up for you. So if you had a bunch of commits up on the repository that weren't on your local, when you do this git pull, you'll get a nice summary of everything that's actually changed since the last time you were working on it on your local machine. So when you're doing the git pull, sometimes when you're doing git pull is actually a shortcut for 2 commands, and that's git fetch. Git fetch is going to be updating that history on your local machine, so updating what your local repository actually knows about. And so again, it's essentially just updating this hidden.git folder, and get fetch does not update this working directory. So fetch right here is asking the remote, bringing that history down only to the history, but not updating your working directory. Git pull is a combination of get fetch plus get merge, and so it's actually going to fetch that information, update the history, and it's going to update those files as you can see them in your working directory. So in most cases, git pull is the thing that you're looking for. Not in all cases, but when you're starting out, I would generally do a git pull rather than anything else. And it's important to do that when you're starting your work for the day, when you're starting or the night, whenever you're working. Before you start making a bunch of changes in your repository, make sure that you have the most up-to-date history from GitHub. If you have collaborators or if you're collaborating with yourself, you want to start with the most up-to-date history. Otherwise, you're going to end up running into some strange and confusing merges and just general frustration because you didn't realize that you didn't have the most up-to-date version and you started from a different point. So always start your day with a good git pull and then start doing your work. And so to review what we've gone through so far in this little demonstration is we learned about git status, and just type that all the time so you can figure out where you're at, what Git knows. You're going to start your day. If you need a fresh version of the repository, you're going to use that git clone to make a copy and pull it down. But if you already have a copy of that repository on your local machine, always start your work with a git pull so that you're getting the most up-to-date information from your remote from GitHub. You're going to make some changes, edit some files. You're going to do a git add to add the file into the staging area. You do the git commit to actually capture that moment, those changes, and put them permanently into the history. And then you're going to do that git push at the end of your day to send all the changes that you've created back up to the remote so that you and other people can see them on GitHub and collaborate there. What I wanted to do really quickly is just kind of show you another way of working through this, because in most cases I'm going to take a more pragmatic approach to working with this repository, and I'm very unlikely to do all of these steps actually on the terminal like that. And so if I go here, here's my project, my demo repository. And in this case, I'm going to right click and I want to open it with code. So I have Visual Studio Code, a kind of light text editor installed on my computer. and that's what I use for editing text and code and stuff for the web, really. And what I have in my text editor here, and this is common in many, and I'm going to make it a little bit bigger here so it's easier for you to see. This is common in many integrated development environments that you're going to be opening a whole folder of files, your project, your repository. You can kind of navigate those files and be able to edit them here. And then there's going to be some built-in helpers here that will integrate with Git for you. So you don't necessarily need to leave this repository, this integrated development environment, to carry out the basic Git commands. And so in Visual Studio Code, what I would typically do is I'll open my integrated terminal. So this is the same terminal as the one that we see here in its own window, but it's just integrated here into my text editor to make it easier for me to just work in this editor without having to switch to a different context. And so I can always do my Git status here. Maybe I'm going to start my day off by doing a Git pull. So everything's already up to date, so I'm good to go. So I can hide that terminal. I can go ahead and just start editing. And I'm going to save that. Maybe I want to go over here in my README and add some more content. So now I've made two changes. I want to add these together in my project, and you're going to see that Visual Studio Code has this helper right here, integrated here, that says a source control panel, and it might be called slightly different things depending on your editor. But this is just Git, and it's essentially using Git in this application and letting me know that changes have happened. And so I can look here to see the diff of what those changes are, which is really a very handy thing. And then I can do my Git add right here in the editor without opening the terminal. So the equivalent of Git add would be clicking this little button that says, this plus button that says stage changes. And if I just want to add them all, my Git add dash capital A, I can do this stage all changes. And so it's just run that command in the background for me. I didn't have to do that on the terminal. And now I need to commit that, but I need a message, right? And so here's a little box to give my commit message. So I'm going to write my message there. If I need a multiple line message, I can just press return and have another line if there's some important description that I need to add. And then to finalize that commit, I've created a message, is this checkbox here. And so, again, depending on the visual tool that you're using, it might have different elements to do this, but this checkbox on Visual Studio Code is to make the commit. So if I click that, that is making the equivalent of git commit -m and then the message that I put in that little box. Now I can open up my terminal again. I can do the git status if I wanted to on the command line. And it's saying, again, I'm ahead by one commit. And so personally, I like to do my git adds and my git commits using this little helper, but I do like to do the push in the terminal because it gives you a little bit more feedback about what's happening. So I always do push and pull on the terminal just because you actually see the output and the results of that command. So I'll do a git push here. And we will push that extra commit that we just made up onto GitHub. And so that's that. It's just a different way of doing exactly the same thing that we did on the command line. And in a realistic, pragmatic workflow, it's likely that you'll do that kind of work using your integrated development environment, whether that might be RStudio, whether that is some other kind of text editor that you want to use in your workflows. There's all kinds of visual helpers, and they are really useful. We're working on the command line today just to get this really fundamental picture of what these commands do. So git status, git pull, git add, git commit, and git push. those are our basics that make up our entire workflow that are enabling our version control. The next video is about looking at this history that we're building up. We have a bunch of commits now in a repository. We can look at that using Git, and that's one of the big powerful things. So tune in to the next video, and we'll see you in a little bit.